Students, myself Sivi Manoj from MIT College. Today I am here with you all to discuss about heredity and variation. This is my second lecture on the topic heredity. Let's start with the lecture. In my first lecture, I introduced the terms which were involved in genetics. We discussed about what do you mean by heredity, variation, genetics, and what are the terms called alleles, then allelomorphous, homozygous, heterozygous, dominant, recessive. All these terms were discussed in my previous lecture. Let's see with the next slide. Whatever progeny was obtained in the F1 generation, they were crossed with each other, giving rise to the progeny which were of F2 generation. These were the steps involved in Mendel's experiment. Let's discuss each of these steps in a better. Now, the step 1 of Mendel experiment. Self-pollinate each pea plant for several generations. That means true breeding or pure lines to obtain self-pollination was taking place. True breeding, all offspring displayed only one form of a particular trait. Whatever offspring were obtained in the F1 generation, they were all same, all constant. So they were true breeding. What is P generation? Parental generation. The first two individuals crossed in a breeding experiment is called as a P generation. So this purple and white flower, when they were crossed, all the plants were having purple flower. So these were the pure line, even they were crossed for five times. So they were the true breeding parents, or pure lines were obtained. And then this was the first step to obtain the pure lines. After pure lines were obtained, the second step was the crossing of this parent, giving rise to F1 generation, which were all identical to one single parent, which was purple flower, and in all the progenies were of purple flower in case of F1 generation. At the same time, when self-fertilization or selfing of the progeny of F1 generation was carried out, whatever product were obtained in F2 generation was this product showed purple color as well as white color flower. Since this white color flower was not obtained in F1 generation, this white color flower which were recessive were hidden. So this is about the step 1 to obtain a true breeding plants, or what again, parent plant. Which is step 2. Cross pollinate the P generation plants with contrasting forms of a trait. What was done over here is cross pollination was done. Now what is this cross pollination? How was this cross pollination done? When you say cross pollination, two plants has to be taken. So these two plants which were taken, how were they cross pollinated? Now for this, I'll take one more slide to explain the second step. Now, when I say cross pollination, which was the second step, or you can call the second step as artificial cross of the selected parents to raise F1 generation. So how was this the step achieved, artificial cross or cross pollination? Whatever plant, whatever flower of the pea flower were there, they're bisexual flower. That means they had stigma, which is a female part, and they also had anther stamen, which is a male part of the flower. So they were bisexual in nature. But one has to achieve the cross pollination. That means what Mendel did, he emasculated the flower before the formation of pollen grains, that is before anthesis. He removed the stamen. You can see over here, removal of the anthers, emasculation, because anthers shows presence of pollen grains. So the pollen grains were removed. The anthers were removed where before the pollen grains were formed. So once you remove the anthers from this bisexual flower, only female part of the flower remains with this flower. Since only female part remains with this flower, this has been cross-pollinated by some other pea flower. So when they're cross-pollinated by some other pea flower, this pollen grains from the second flower was dusted on the stigma. This is the stigma. So this was dusted on the stigma of the part which was emasculated, on the flower which was emasculated. Here you can see transfer of pollen grains. I repeat my statement, emasculation is nothing but removal of anther from bisexual flower to make it a female flower. Now this was done, removal of anthers, which was emasculation, was done of this flower. That means the male part of the flower was removed and it was left only with the female part. The other one more male flower was taken. The pollen grains of this male flower was dusted on the stigma of the emasculated flower where only female flower was done. So this is called as artificial cross pollination. So second step was artificial cross pollination was achieved by emasculation. So this is the second step of Mendel's procedure. Experiment you can call it as. Next step, third step. What was the third step? Third step was he allowed the F1 generation to self-pollinate. That means cross-pollination was done over here in the second step. Then what he did, he allowed the F1 generation to self-pollinate, and finally he achieved the second generation, F2 generation. The offsprings of the F2 generations were achieved by selfing the offspring of the F1 generation. Then he counted each one of them. Characterized and count plants means he characterized and he counted each one of them. That is what he want to say. That means how did he characterize? 1, 2, 3. Out of this 4, 1, 2, 3, 4 flowers, 3 are purple flowers and 1 is white flower. That is 3/4 of the plants have purple flowers and 1/4 of the plant have got white flowers. This is what is Mendel experiment. Steps are 1, 2, 3. The first step was what you call it as pure line to obtain. Second step was by artificial crossing, by emasculation, and third step was crossing the progeny of F1 generation to obtain F2 generation. So this is a Mendel's experiment. Now what is next now? Let's see the different Mendel laws. How many Mendel laws were there? What are those Mendel's law? It's quite funny to see those cartoon pictures. Okay, next. Now in Mendel's law, there are 3 laws. First law, second law, and third law. First law is called as law of dominance. Second law is called as law of segregation. The third law is law of independent assortment. Now, what is this law of dominance? Law of dominance states that if 2 alleles at a locus, locus means the site or the place or the position on the chromosome of the gene. If 2 alleles at a locus differ, then one, the dominant allele determines the organism's appearance. The other, which is a recessive allele, has no noticeable effect on the organism's appearance. That means the dominant allele is expressed while the recessive allele remains unnoticed. That is what they want to say, the law of dominance. There are 2 alleles present on the chromosome. They are present at different locus or the position on the chromosome. One is dominant allele, the other one is recessive allele. The dominant allele will be appearing in the organism while the recessive one will be hidden in the organism, and the one which expresses the dominant one, which is called as law of dominance. Now what is the second law? Law of segregation. This law of segregation, in this what they were, segregation means separation. The 2 alleles for a heritable character, they separate or segregate during gamete formation and end up in different gametes. That means what they want to say over here is law of segregation or law of separation is nothing but the separation of the alleles during gamete formation. So whenever there is a gamete formation taking place for crossing or selfing, the alleles from the alleles, the gametes are separated during gamete formation. That is what they want to say. Law of independent assortment, which is a third law. According to this third law, law of independent assortment, each pair of alleles, they segregate independently of other pairs of alleles during gamete formation. Now here the 2 pairs they are calling. Here law of dominance, law of segregation is following seen in monohybrid crosses. When we're talking about law of independent assortment, we're talking about dihybrid cross. Law of independent assortment in which dihybrid cross is seen. So dihybrid, di means two. So two contrasting characters are taken. For example, height of the plant or the color of the flower or the position of the flower. That means two contrasting characters are taken together. But each of the character, they are segregated independently during gamete formation. This is what is law of independent assortment, because here two pairs are taken and each of them can be expressed, segregated, assorted independently during gamete formation is the third law of independent assortment. Again, I repeat, law of dominance, law of segregation is followed by monohybrid cross, while law of independent assortment is carried out by dihybrid cross. Now let's see each one of this in a very what do you say, in a better way. The first law, which is the law of dominance. In this, what they want to say, every gene has two alleles that can code for a trait. Trait means a character. The character can be contrasting all those any of the seven contrasting character. So one character, if you take, it has got two alleles. For example, if this is one allele, say round is one allele round. So one R and other R. So these are the two alleles for one character. So this is dominant and this is recessive. The only difference, this is homozygous and this one is heterozygous. But this is homozygous dominant, this is heterozygous dominant, and this is homozygous recessive because it is small r. That is, each of this character has got two alleles, one capital R, two alleles, one small r, two alleles. They what do you say? They code for a single trait or a character. Now, one allele is dominant, meaning it will always show. One allele is recessive, meaning it will be marked by the presence of dominant allele. Now, this is dominant and this is recessive. But when we see after the crossing of this parent, whatever progeny we obtained in F1 generation, they showed capital R, small r. So when they showed this capital R and small r, it says that capital R, small r, that means this purple, this red color, or we can say purple color, was expressed over here, which was dominant. But the small r, which was recessive, was not expressed even though it was present with this capital R. So I can say this one capital R is one allele, the other small r is the other allele. So the capital R, which is dominant allele, is expressed in presence of this small r, which is a recessive allele. So hybrids will always show the dominant phenotype. So whatever hybrids were there, they were of dominant phenotype. What is phenotype? It is the external appearance of a particular, what to say, of a flower or a plant you can call. Here we are talking about pea plant. So it is external appearance is phenotypic in nature. And genotype means capital R, small r hai. Yeah, capital R is it, or is it small r? That is a genotypic form. Genotypic means genetic constitution, the genes present in that particular plant. Now here it is capital P, purple. When they were crossed, what we is obtained, capital P, small p, that is a purple color was obtained over here. That is what is law of dominance. The one which was dominant is been reflected even in the presence of a recessive one, and the recessive one was hidden. This is law of dominance. The next law is law of segregation. What is law of segregation? The law of segregation states that the two alleles coding for the same trait, they separate during gamete formation. Suppose the two alleles are this, one is capital Y, other one is small y. This capital Y, small y, if you see over here, is this capital Y, small y is one trait, but it has got two alleles. One is capital Y is one allele, small y is the other allele. Now these are the steps involved in gamete formation. So this gamete formation, when it is taking place, when it is taking place, what is happening over here? There is a separation of this capital Y and small y. That is, these alleles are separated. That is what is law of segregation. Segregation means separation. Law of segregation states that the two alleles coding for the same trait, they separate during gamete formation. That is, this separates, this alleles, they separate during the gamete formation, is the law of segregation. Now let's see what is the next law. Now, before you go to next law, let's see a diagram or a flow chart which is representing a Punnett square representing the law of segregation. Now, in this case, this is a female parent and this is a male parent. This female parent is represented by a heterozygous condition, capital T, small t, and the male parent is represented by capital T, small t. Both are heterozygous dominant, that is, both are tall. Capital T stands for tall and small t stands for short. Now this is a female parent, this is a Punnett square. On this top of the Punnett square, what is the female parent is written, female gamete is 1:1 ratio, and this is a male gamete, 1:1 ratio is written over here. Then what is done? Then there's a crossing taking place between the male and the female, and whatever is obtained in this square is nothing but the F1 generation, and it is phenotypic. Phenotypic means what? The externally how they are appears to be. Now when the crossing taking place, that is capital T is crossed by, whatever you get is, when this capital is crossed with this capital T, you get capital T, capital T. When this capital T is crossed with small t, you get capital T, small t. When the small t is crossed with capital T, you get capital T, small t. When the small t is crossed with small t, you get small t, small t. This is what is a Punnett square. And whatever is obtained over here in this is the F2 generation. Now this is nothing but called as phenotypic ratio, which is 3:1. This phenotypic ratio is, why 3:1? Because 1, 2 and 3, all these three are tall, because this is homozygous tall, this is heterozygous tall, this is also heterozygous tall, and this one it is only one, which is a homozygous short or dwarf, we can call it as. It is also homozygous because it is small t, small t. The only difference is this is recessive, so they are dwarf or they are short, and this ratio is 3:1 because there are 3 tall and only 1 dwarf, so it is 3:1. So when this is phenotypic ratio. So when I'll ask you what will be the genotypic ratio, genotypic ratio will be 1:2:1. Why it is like that? Because even though this phenotypically they are tall, they are different in their genotypic constitution or genetic constitution. Why they're different? This is homozygous dominant, so this is 1. This both are heterozygous dominant, this is 2, 1, 2. So 1:2, and this is homozygous recessive, this is 1. So 1:2:1 is a genotypic ratio. So this is about law of segregation. What they're saying, independent assortment. In each pair of alleles, they segregate independently of each pair of alleles during gamete formation. Now, this is one pair, this is the other pair. Now, whatever is a cross, each pair has got its own, what do you say, it can express in presence of the other pair independently. That is what is law of independent assortment, that is law of segregation. They are independently, they can segregate or separate from each other. So this is what is a supportive one for dihybrid cross of independent assortment, which is the third law of Mendel. This is a phenotypic ratio they have expressed over here, 9:3:3:1. In this 9:3 means what? 1, 2, 3, 4, 5, 6, 7, 8, and this is 9. So 9 is this. That is yellow and round. And what is this? 3. This 3 is green and round. This 3 is nothing but wrinkled and yellow. This is wrinkled and yellow. Wrinkled and green, you can call this. So this is what is Punnett square checkerboard for the dihybrid cross, which is supporting the law of independent assortment. So that's all for today's lecture. Thank you.